There's a lot going on. Boom. And then terminal.
I don't need it.
Oh, yeah. Yeah. And then what the thing there. All right, cool. I think you're good to go. Just one last sound check. Can everybody else hear me now that I got everything recording? Just somebody say something out loud or type in the chat. Yeah, I got something in the chat. Okay. Good stuff. All right, you're good to go.
Oh, can I just see it? With the podium over here? Great. Okay.
Cool. And check this.
All right.
Good. I think you're good to go. Just try to stay close to the computer this time.
Sure. All right, so if you didn't get a chance to scan the QR code to fill in the attendance form, please do so right now, or we'll make the announcement. If you don't want to listen to the announcement, let me close the door. And also, like this, some general advice on answering the random questions. Okay, be creative, because a lot of you are not being really creative on the past few ones. Yeah, I'm sad. But yeah, so okay, we're in week 4, and some of you probably have had the 61A midterm yesterday, right? Yeah. How was it?
It was fine.
It was fine.
It's easier than the practice.
Yeah, much easier than practice.
Wait, it's easier than DeCal?
No, it's
Oh.
Yeah, but the test paper like 60%, and for the real exam is much easier.
I don't know. I genuinely don't know.
But anyways, so what we've been doing may overlap with the very beginning of 61A, right? But from today, we're gonna be like completely on a different track from 61A, right? So a few announcement first. Oh, why is this not working? Okay, there we go. First one, second homework is just due. I know some of you joined late. You guys will have an extension, so don't worry about that. And then if you're having technical difficulties on converting to PDF or uploading the homework because of our really bad internet over here, please let us know as soon as you can. Okay, so we will penalize you for submitting it late. And then office hour. Thank you for everyone who came actually. Yeah, so keep coming to office hours, especially mine, you know, like Friday afternoon. Ooh, Friday afternoon when I'm over there, like in that room, no one came. Yeah, and that's just sad. Okay, Friday after, I'm bored at Friday afternoon, so are you, but please come and talk. Yeah, and the attendance form is over here for whoever that's watching remotely later. Yeah, okay, stuff. Some recap. Last week we did recursion and dictionary. So well, first question is, what is a recursion? Anyone? Yes. Sorry? A what? Calls itself? Function. A function, when a function repetitively calls itself, and that's what a recursion. So like what would be some applications? Yeah, that's one of the classics. Yeah. And the other one is for dictionaries, right? So how are dictionaries different from lists? Anyone? Yes.
With a dictionary, you got some kind of key, and you use that, like the keys are paired with some of the values. You can access the value by
So like in list, you can only index by some number, right? Orders. And also dictionary doesn't really care about orders that you put in stuff. Every time you call a dictionary, it might appear differently. But the information stored in the dictionary is the same. So you don't have to care about orders at all. It's just, yeah. All right, so far in the past 2 weeks, we've only been introducing you functions and also some very basic usage of Python. So like we're using the built-in functions, like say for example, print or the for loop. Those are already built into Python. But from now on, we're gonna make our code more powerful because there are only a limited amount of stuff that we could do with the built-in with stuff that's already built into the language. So how do we make our code more powerful? Ideas?
Import stuff that people already.
Whoa, you know the stuff. So you do import. So there's this thing called import statement, which is like say the statement is a package. It's really is a package. A package is you can think of a package as a whole bunch of functions that other people has already written up for you, and you can just use it straight away instead of writing your own. So for example, the Fibonacci sequence, right? It took you guys a lot of time maybe to write it up or like some other recursion stuff, right? But there must be someone else in this world who has written a function already about the Fibonacci sequence, and you can just use it straight away to generate it. It's like a shortcut. You don't have to write everything on your own. So another thing is calculating average number, right? There is also some functions that does that, which we'll introduce to you later, right? To import a statement, and we've already imported math already. That's already a package that we did a few weeks ago. But there's also like packages called random, numpy, and also much more stuff, which we will be telling you in this week and next week, and maybe the day after, the week after, as well, right? So I was saying, say for example, calculating mean. We know the formula for mean. Is there a formula for median? How like without importing anything? How would you write a function that calculates a median of a list with 10 elements in it? Yeah. Whoa. Could someone paste the attendance link again? Oh, don't worry about the attendance link. You can fill in afterwards. I will go back to that. Or maybe some of the instructors could paste the link. Right, great, thanks. Yeah, wouldn't show.
Like when I called it, like when it
Oh, maybe.
is it in the file?
Yeah, it's on the slide. We can send it to you later as well. Yeah, don't worry about that. Yeah. But back to the this median stuff. How would you do that? Third?
I just sort the list and then like find the average of say the 56 value. Well, not 56 index, well, fourth index.
How many lines of code would that take?
Well, if there's already a function.
We have to think about it, but like, so the way to only use the built-in functions of Python, is going to it's gonna take your like you have to burn some of your brain cells, right? It's just like a little bit too much of like in the middle of the night if you want to find a median of a list. I don't know why you want to do that, but if you want to do that, it takes energy. Yeah, because I have to do work, right? But there are, whoa, why? But with packages, you can do a bunch of stuff. I'll tell you later. But how do we import a package? Which is literally doing this. Import package name as an alias. That as an alias part, it's optional. So say we imported math in the past weeks. We didn't really say like math, import math as something, right? But say there are packages with a really long name. For example, matplotlib is a plotting package. We learned that. And it was a really long name. You want to abbreviate it into some shorter names. It's like assigning this package into a variable. Remember like how we name a variable, like x equals something. This is the package equivalent, the import equivalent for that. For example, right, which we're going to be talking about NumPy today specifically, you import NumPy as NP, right? Or you can just simply do like import NumPy. I mean, it's the same thing. But if you do import NumPy as NP when you call it this package, you can just do NP instead of like typing this 5 letters every single time you call it. And also the way you name this thing, this NP stuff, this is more conventional, but you can also name it something else, right? You can import NumPy as DeCal, but every time you just when you call NumPy, you just call DeCal or whatever, right? It's of your choice. And in general, we import a package at the very beginning. of your code. Sometimes I do in the middle of the code because just forgot to impact some package. But in general, for like 10 minutes of the code, what is it? What is the word? Coding hygiene or whatever. Yeah, you put it at the very beginning, so you won't miss a thing. Here we go. Okay, so from now, this is going to be the most important lecture you will have this semester. This is going to be your friend for the next few years, actually. If you're going to continue astronomy or physics or any coding related stuff, NumPy array is your friend and your enemy as well. Yeah, so it's the most used tool in science, actually, array, because it has some superiority over lists. Say, for example, this is a list. See the square brackets. If we forget about that, that's a list that we introduced in the first lecture. And then we have the NumPy array, which is sort of defined in this way: NumPy.array, and then you put a parentheses within it. You put a list. And when you call this ARR, this array, it just gives you the array. Yeah, nothing special. And the indexing rules are exactly the same as lists. So this is the 0th element, the first element, second, third, fourth, and then also all those indexing rules that we talked about when we're talking about lists, they still work, right? Yeah, but like that meme said, what's special, right? Because it's superior. I said it's superior. But how is it superior? So if I define these two lists over here, and then if I multiply them, if I add them together, what would be the output? Yes.
Adding them together to get the list twice, like you get the list back to back.
Right, you get another list, but it's like twice as longer, right? Yeah. What about multiplication?
3 times as long now.
3 times as long. But say if you want to add, you want to double the entire list, like the values, each value you want to double it. What would you do? Well, without NumPy array. Right, you have to sort of define a new array or like replacing like for I in range, whatever, right? And then yeah, that just it takes energy as well, and you don't have that much energy in the middle of the night. So this is how it's superior. If you define two array, which almost looks identical to list, and if you add them together, or you do multiplication, NumPy array acts element wise. So if you add the two array together, like this array 1, array 2, each with how many numbers are there? Like 8 numbers. If you add them together, if you add two arrays together, each element adds. So it's going to give you 0, 2, 4, 6, 8, 10, 12, and 14. Each of the elements is doubled. And then you can also do multiplication by a scalar. And each element will be tripled. Yes. Yes, exactly. But how do you think it's going to work? Well, no, because dot product has a plus sign. For two vectors, if you dot them together, you guys don't need to know about what dot product is. Dot products, you get a scalar, a single number out, right? But you're almost correct. Each element they add. So if I multiply these two together, right, you will get 0, 1, but 2 squared now, 4, 9, 16, 25, etc. Yes.
So is an array different than a matrix?
It's essentially a vector or like a matrix. Yeah. Yes.
What if there's different numbers, there's 8 numbers in the first array and 12 numbers in the second?
Good question. What do you think?
Keep the numbers.
No, it's not gonna work. To do this element-wise operations, the two arrays or how many arrays you have, you need to have all the arrays in the same to have the same length, to have the same size as well. Yeah.
How do we get two like higher dimensional arrays, like 2D arrays?
Good question. They also act element-wise. Yeah. So it's just like whatever that's in the position of the first array gets operated into the whatever that's in the second, whatever that's in the same position of the second array. Yeah. Yeah. If you multiply two array with different lengths together, so for example, we're only talking about 1D for now. Okay. Yeah. You would just get an error. You wouldn't get like anything. It just pops out. So sometimes it's a way to check if your code is right, if your code is running. Yeah. Okay. Yeah. So what can I do with all this 1D array? Yeah, we can. So calculate mean. That was one of the examples, right? How do you calculate the mean? You add all the numbers. You divide by the total number of elements that you're adding, which is in Python language is just the right sum of your list divided by the length of your list. But with a NumPy array, you can literally just do NumPy.mean and it calculates the mean for you. You don't have to think about like adding everything together and having any other troubles. Note that your array, although I put your array here, it could be a list as well. So this is really an array-like object. Okay. So an array-like object is like a list, an array. Not sure if tuple counts, but no one uses tuple for operations anyways. So a list, an array. Yeah, they can all go in here. Yeah, that's fine. You can also calculate standard deviation. Anyone remember what the formula is?
Square root of something.
What is that something? See, like it takes energy, like to just to recall it, right? And then if you don't know, you have to go check a textbook or Google it or whatever. I mean, you're not sure if Google is correct, right? But then with NumPy, you can do this, right? You can just literally do numpy.std, which stands for standard deviation, and you get the standard deviation out. Yeah, which is pretty simple. And also the reason why I put San Diego over here is because when I was the first year, there was this guy was like slightly older than me, calling like standard deviation San Diego. So like sometimes I just adopted that. Like I'm like one San Diego above the average or whatever. Yeah, they are. I guess no one talks like that anymore. Yeah, and also percentile. I don't know if you know what a percentile is. Yeah, it's like a bound. A bound is an upper bound for if you have a sample, if you have a whole bunch of sample, right, and then a whole bunch of number, and then for example, the 50 percentile would be the median. It divides the sample into half and half, right? 60 percentile, like you will get the boundary for like a list of a list of, sorry. a list having 60% of the entire sample. Yeah. And also the median thing, right? If you don't know the dimension of your array or the length of your list, and you want to count the median, this is how to do it. NumPy.median. You don't have to write your you don't have to sort it first and then calculate the median actually in the middle. I don't know what the middle is, right? Yeah. Any questions so far? Pretty straightforward. If you guys got like problems in like, yeah. What do you mean? It's a float. Normally it's a float. Yeah, normally it's a float because I never really paid attention to the mean and the data type of the output, but so because I normally just assume everything's a float, so yeah, which is not too big of an approximation, you know, so that's actually fine. So no question on 1D array. There are other stuff you can do with arrays though. These are it's not limited to these. Yes.
I'm just curious about some other like how strings are treated. What a string considered like an array of characters that must be operated on, like with these methods or these functions.
In Python?
I'm just wondering in Python, could you basically apply these array string, array functions of string.
No, like this one specifically, no, for sure, no. But I personally don't know any function that acts on both array and strings, other than the indexing part. Yeah. Right. No more questions? We're good. Great. Now we're going to higher dimensions. Ooh, 2D arrays. 1D array would be our friend. This is one of the closest friends. Yeah. So 2D array has 2 dimensions. Dimensions just means like dimensions. Yeah. Yeah. But the general form of a 2D array is literally like this. You do like numpy dot array, but it's like you have 2 lists within another list inside this array statement. Oh, sorry, I missed a parentheses over here. Yeah. And then you can think of it as a matrix, right? How many of you know what a matrix is? Oh, that's a lot of you. Okay, yeah. If you don't know, that's fine, because we don't ask you to do that anyways. I don't know what a matrix is, but anyways, yeah. I can explain it. I can actually. Yeah, but you can store some different information, like other than thinking of a 2D array as a purely mathematical concept that's called matrix. You can also think of it as a table, right? You can store different information in a 2D array. Say for example, when you do physics, right? One of the fundamental variables, sounds so weird, is position, right? A position on a 2D surface is defined by x and y, right? So each, I'm seeing another parenthesis over here. Anyways, so I can store the x positions of 5 particles as one of the elements in the array, and I can also store the y positions of the same 5 particles as another element in the array as well. I'm missing a lot of stuff. I'm sorry. Let me draw it here. This is annotate, and you should have another square bracket here, and a parenthesis here, and a parenthesis here. There we go. Now we're fine. Right. Questions so far? Yes, you can go. You can go to n dimensions. Yeah. And geometrically speaking, that's like a cube. Mathematically, it's a tensor, right? Yeah. Say for example, no, I can't think of one right now. But I've used 3-dimensional arrays before, and it's a lot of trouble. Yeah. Yeah. What is this? Oh, yeah. And why is 2D array useful? One of them is that when you do physics, you may have some 2D distributions, like I don't know, number density of particles on a surface, right? How many particles do you have, like on this part of the table? How many particles have on the other side part of the table? You can quantify that using a 2D array. In astronomy specifically, images. Yeah, we literally all we do in astronomy before gravitational waves was counting photons. That's all we do, right? That's all. We see the entire. We get all the information from the universe from photons, right? And then images are essentially 2D arrays. All the images are 2D arrays. The way it works is that in this case, where I have an image over here, what's the smallest unit on the image? A pixel. Yeah, a pixel. So I can say my image has like, I don't know, huge pixels over here. And then each pixel is characterized by a number. That number could be like, say, brightness, right? Like if I have a super bright object, like somewhere over here, if I take a picture of the sun, don't do that, okay? If I take a picture of the sun, I will have like very bright, some very bright source in this area. So maybe in some of the images, you could just, all these pixels are 1 over here. And then but 0 on the other side. Whatever. Right? Does that make sense? So for images specifically, you can think of these 2D arrays of brightness of each pixel, and then your computer somehow just convert that into an image that we perceive, right? Yeah, and these are and these are some of the data that I've used in my research. This one is a debris disk, a circumstellar disk, a whole bunch of dust particles around a star, from which planets may form. That one is a spectrum of an active galactic nucleus, and then both of which are images, and then which are 2D arrays. And then we manipulate these 2D arrays to get the information that we want, right? So these are your friends, closest friends. Questions so far? Good, good. Okay. Oh, what's going on? Oh, they're still there. Clear. All right. And now this is the hard part. This is the hard part. So as I said before, a 2D array has 2 dimensions. One of them, I'll just put this array in terms of a matrix over here, so it's easier to visualize without all those like words. Indexing for 2D arrays is similar to 1D arrays and also lists, slightly different though. Because you have 2 axes over here. All these axes, you can call them dimensions as well, but like for the Python language, we'll call them axes. So axis 0 runs vertically, so it counts the row. Axis 1 counts the columns. And you can also, yeah, so over here, axis 0 counts like each of these arrays, these subarrays. Axis 1 counts the columns. Does that make sense? All right. Good. And also you can have more axes, like we talked before, which are just like you have like 3-dimensional tensor and then 4-dimensional tensor, maybe 100-dimensional tensor. I don't know why you want to do that, but you can do that. But then this is what we call array slicing or array indexing. Right? Slicing is the proper word. So this is the same array as before, and I just abbreviated as my variable name ARR over here. And say I want to call I don't know, this 3, right? That's what the example says. The 3 over here. What I would do is I put a square bracket after my array over here, which is the same as the indexing of lists and strings. But then any number in a 2-dimensional array is characterized by 2 numbers. One along the x-axis, one along the 0th axis, the other one along the first axis. Make sense so far? And then, so that means the first number, our first number is indexed along the axis 0. The second number is indexed along axis 1. So it's like the x, y coordinates of these numbers inside the array. Make sense? So the 3 over here, this 3, you see, like the index along axis 0. So you just count the rows first. So this is the 0th row. This is the first row. And then now we have the row over here. Now we just count a column. So this is 0th column, first column, and then the second column. So the index along axis 1 is 2. Okay. What if I want to do this? Find this 3 over here on the bottom left corner. 3, 1. That's going to give you an error. Why?
It's not, oh, it's absolute or-
Because index starts with 0, right? Yes, 2, 0. What about this 1 over here? 1, 1. Good, good. So this is called array indexing. It's kind of easy. Maybe. I don't know. When I have a large array, sometimes I get confused. Any questions?
Yeah, do one more. I mean, let's get one more.
Oh,
One
sorry?
more. Yeah. one more.
What did you say?
Oh, I want another number.
Oh,
Got it.
that one.
Sorry.
That one will just be 0,
1, 2.
0, and 1. Because this is a 0th row, but the first element. Yeah. So the first number counts the rows.
Yeah, we're gonna-
Second one counts the
I don't know why, but I was counting.
counts the columns. Yeah, yeah, it's a little bit it's a little bit confusing when I first learned it. Oh, some of the ways to check it, like if you get the correct one, it's literally just try. Like there are only 2 combinations, 1, 2, or 2, 1. See which one gives you this number, right? That's normally how I check, especially for higher dimensional arrays. And also you can also select everything along the axis. Say for example, I want this entire column over here, right? Everything in Python is sort of indexed by this column that we haven't counted before when we were saying like we want the second element and everything after that. What we did in list was this, some list. And then that's the index indexing we did. Questions about that? Okay. So that column over here, that sort of represent the concept of everything. So I want to select the entire column. So that means I want to select all the elements along the row. That makes sense? Right. So I want to select all rows, which is what this is saying. This is row and column. I want to select all rows, but only on the second element. Right? The second column, sorry. Make sense? Okay. What if I want to do this 1, 2, 3? This first column over here. Column 0. So you had a question? Oh, sorry. Yeah. Okay. Now here's the challenge. What about the first 2 columns?
Zero.
Yeah. Yeah, that's what you do. Actually, 0, column 2, I think. Yeah.
Okay.
Yeah. So to call both columns over here, right? The first, the 0 and the first column, what you're going to do is you're going to be calling all the rows anyways. So the first one's still a column. But then on the column, you have to call 1 and 2, right? The way to do that in Python is 0, column 2, right? So that's the 0. You're going to pick out the 0th and the first element out of the array. Questions? It's confusing. It looks easy now. When I actually work on it, sometimes I got it like the wrong way. Yeah. So I can't hear you. What? Yeah. Sorry, I can't hear you.
Once you write on the board.
Oh. Wait, I don't think I answered your question.
So if I were to put it in, right, and I wanted to do.
Oh, like as an entire code.
Yeah.
Oh, sorry, yeah. Yeah. So this is your array over here. Can you guys see it? Okay, great. So this is your array. But I want everything. I want a column. So the row is a column on the row position. But the column, I want the first 2 columns, right? So it's going to be from 0 to 2, right? Or you could also do, maybe you can't see, just get rid of the 0. Yeah. But the comma is is necessary. Like you have to put a comma over there. Otherwise, it means something else. Yes. Yeah. If you're counting from the very beginning, it's optional. Okay. What about the last two columns? What?
1, 2, 3.
1, 2, 3. Yeah. 1, 2, 3. Or there's another way. No. Oh, negative. Sure. Yeah. You can also do this. All right. You only use negative when you have a huge array. That's like when negative is sort of useful. If you have an array with like 100 numbers in it, maybe negative is a better idea than going counting from the beginning, right? What if I want to pick out the entire row? Say the second row, the first row over here. You flip it? Sure, yeah. But what's the first number? It'd be 1, yeah. Because like remember Python comes from 0, right? So it'll be 1. So it's gonna be if I want to count pick out the first row, it's gonna be array on the first row with a column. That means I'm picking all the elements. I'm picking all the columns, which is a row. Yeah. Does that make sense? Every year when I teach this, it's confusing. Yeah. Right. And now we want to do like there's this thing called axis twice operation. So you have to be really familiar with all these axes now. Say if I want to calculate the mean, right? Say of all the rows, mean of all the rows. You can't just simply do a numpy.mean and then you put an array in it, because that's gonna give you the mean of all the 9 numbers, the entire thing. You just want the sorry, the row along one axis or along one yeah, you only want the mean along one axis. So what you do is in this numpy mean, numpy median, numpy percentile, and numpy standard deviation functions, we put this axis variable or like axis argument in it, and then you specify what is the axis what along which axis you want to calculate your mean. Does that make sense?
So
Yes.
could they replace that word like axis equals 0 with just like the word like rows? Is that what you're talking about, like the rows?
So what do you mean?
Does it mean the rows?
Oh, axis 0? Axis 0 actually means you're calculating the means along these axes. So you're calculating the mean of each column.
Oh, column. Okay.
The axis
Got it.
0 means you are calculating
okay.
the means of each column.
Okay. So the two columns. Oh, 0 is a column.
No, 0 counts this way. But when you do axis equals something, no, this is confusing. That's a good question actually. Yeah, because I was trying to figure it out myself as well. Yeah. That's why I chose this example specifically, because you see over here, the median is 2, 2, 2. So I know which axis this is. Yeah. But yeah, I still make mistakes on this one. So especially there are only 2 axes, try it out. Okay. Yeah. So axis 0 means you're calculating the mean of each column, and axis equals 1 means you're calculating the mean of each row. Does that make sense? Because you are doing the average along axis 1. So for every row, that's how you do it. Does that make sense? And then the standard deviation percentile, they all follow this thing. And also like say if I want to sum the entire row, I do axis 0. I sum along axis 0. No, sorry. If I want to sum the entire column, I'm sorry, I misspoken. Yeah. If I want to sum over the entire column, I do axis equals 0. So I'm summing all the numbers along this axis. That makes sense? Yes. Yes, it returns 3 values. So if you sorry.
This is a new array.
Yeah, it's a new array. Any array operation, it outputs a float or an array-like object. Yeah. Yeah, but if you just simply do numpy.min, it's going to give you a float. It's not an array anymore. It's just going to give you a float. There are special arrays like this. Not a lot of people use this. You just have one number in it. That's different from a float. Okay. Sometimes weird functions give you this output, but in most cases they don't. Questions? Yes. What do we add elements? Sure, you can do that. There is this thing called how do we add elements in lists? No, how do we add elements in lists? Append, yeah, append, yeah, list dot append sort of stuff. So this is how you do it. This is how you do it. So sorry. I have a list, and now I want to append something. This is how we do for list. Append, I don't know, something, right? This is how we do for a list. For tuple, you can do this because you can change tuple. For arrays, though, you can do this. Like Python doesn't recognize it. What array does is this numpy dot append function. It takes in two variables. One of them is the original array. The other one is the something you want to add. And can we have different data types in the list? Yes or no? I can have a list of like with strings, tuples, lists, dictionaries, floats, integers in it. Can we have that? Yeah. Yeah, right. Yeah, of course we have. Yeah. These are like trash can, right? But arrays don't take different data types. So all of the data in your array has to be in the same data type. And mostly that's going to be float and or integers. No one stores strings in it, right? Why? And this thing, if you just simply call that, that's not going to give you a new array. That's just, you're just doing this thing. It's not saving anywhere. So normally what you do is you say array equals that. Yeah. And then you should really like Google this function. Yeah. And there are also other arguments saying where I insert this element. Yeah. And say this is like a simple case in 1D array, you just put another number, that's fine. But in 2D arrays, you have to put in, say for example, you can't just simply, this is a 2D array, you can't just simply add a number over here. Right? You either add a column or you add a row. Right? And that's specified by the axis argument. Yeah. Any other things about arrays? Questions? No more questions? I guess we're finishing early today. Yeah. Yeah, that's all we have for arrays. I mean, I don't have demos because the things are, people don't understand with demos with array slicing anyways. At least I didn't. When I did, people still made mistakes on their problem sets. So I decided not to do demo. And also because I was too lazy. Yeah, if there's no questions, we're done. We're 3 minutes early. Yeah.
Homework 3 will be uploaded like right after this, and we will post the slides after the next one. Not the
Oh,
Can we have it down?
I'm sorry. Array. Yep. Okay. But it really can be like generated. The way we do that though, is say, sorry. Okay, we got that. Say, the way we do that. And then, yeah, like, it was like maybe for I in some range. Yeah, for array I equals maybe J or whatever. Yeah.
Right now it's just gonna be like.